Hello and welcome to Keep Coding. In this video, we're going to see about how to create a queue using Go. We're going to use generics and we're going to use linked list. So this is the second video of the series where I'm doing a lot of data structures. Earlier I did stack. You can check the video. If you don't want to miss the future videos, please subscribe. Now let me create a new package named queue, and within that I'm going to create a new file named queue. Okay, so here I'm going to create a new package, which is what I'm going to use in the main to demonstrate how the queue is working. Okay, so now first let's understand what is a queue. Unlike a stack, a queue has two ends. It has a front end and a back end. A stack has only one end. It has a top end, and then you'll be able to add items to the top, and then you'll be able to take items only from the top. Okay, but unlike a stack, a queue has two ends. It has a front and a back. Okay, and then you'll be able to add items to the back, and then you'll be able to remove the items from the front. Okay, so if this is the front pointer, we have a back pointer, then the queue look like this. So there is one item, and then there is another item, there will be one more item. Okay, and so if I have to add a new item, I have to add it at the back, which means after C I have to add it here. Okay, and then if I have to remove the item, it will be removed from the front, which means A will go away and then B will be the first item. Okay, so we call these operations as NQ and DQ. Okay, so NQ is the one where you add an item to the end of the queue, and then DQ is the operation where you remove an item from the front of the queue. Okay, other than that, we have one more operation named peek, which will tell which item is there at the front currently. Okay, it will not remove any item, it will not modify the queue, but then it will just say which item is there at the front. Okay, so just like stack, we're going to use linked list for implementing this. Since I'm going to implement a linked list, I need a private structure named item, and I'm going to use generics because so that I can use this queue with any type. Okay, so this item is going to be the individual items A, B and C and D. Okay, so this will contain a value, and then it will contain a pointer which will point to the next item. Okay, so it is going to be value is going to be of type T, which is a generic type, and then we have a next pointer, and this is going to be a pointer of item T. Okay, so here I have to specify the constraints. I'm going to say that T can be any type. Now this type is what I'm going to use in the actual queue. So if you see, I have kept this as a small letter so that it will be a private item. It is not available outside this package, but then this will be available outside the package. Okay, so this is going to be of type T, generics. So here, unlike a stack where we have only one pointer to the top, we have two pointers, right? So I'm going to have a front, and then front is going to point to an item of type T, and then I'm going to have one more pointer for the back. Okay, and it is going to have the same type. Item T is what is going to point as well. Now we're going to implement all these operations in queue, DQ and peek. Okay, and say I'm going to add a function, and this is going to be applied on the queue. So I'm going to say queue of type T, and then enqueue. So when I'm going to enqueue an item, I am going to take a value in, and then the value is going to be of type T, and then add it to the end, right? So if you see, we are enqueuing an item to the back. Okay, so the first step is I'm going to create an item. Okay, and then value is going to be this, which we are getting from the outside, and then the next pointer will be nil, because since this will be the last item, this is not gonna have any other item after this, right? So the next pointer will be nil. And if you see, I need to specify the type here as well. Since it is generic, when we are instantiating something, we have to pass the type as well. Okay, so now I've created an item. Now this item should be added to the back of the queue. Okay, which means queue dot back dot next is gonna be item address of item, since it's not a value. And after this I have to update the back as well. So the back is going to be queue dot back dot next, because I added a new item behind back, and then I'm updating the reference to the back to the next item. Okay, but this is not enough. We are only looking at a scenario where we have multiple items where we add something to the back. In an empty queue, what happens is that there won't be any element, and then when we are adding the first element, this element is going to be both front and back. Okay, so this case is something that we have to handle. So in an empty queue, the back will be always nil at the beginning. So if queue dot back is equal to nil, which means it's an empty queue, then what I have to do is that I have to update the front as well. Okay, so the queue dot front has to be this, as well as queue dot back has to be the same. So now we are handling that empty queue scenario, as well as when something is not empty. Okay, so here I have to add a return, so that I exit from here as soon as I add the item. If it's not the case, if the back is not nil, then the queue is not empty, and then I have my regular way of adding things at the back. I'm not gonna touch the front, because the front is already having a pointer to the item which is there at the front. Okay, now we're gonna add DQ. Okay, so here I'm gonna say queue. Actually, I don't need a pointer to queue. I'll update that as well. Here also I don't need a pointer. Okay, so while dequeuing, I'm just gonna return value of type T, and if the queue is empty, then I have to send a false. Okay, so I'm gonna return a bool as well. So the purpose of the bool is, I don't have to specify the name. The purpose of bool is that if the queue is not empty and I'm returning the value from the front, then the bool will be true. Okay, if the queue is empty, and I'll be returning a value anyway, which will be the default value, and that value should not be used. Okay, so for that purpose I'm gonna send a false in the bool, just like how the map is working. That's how map is working in Go. So if you try to read a value from the map using a key, then it will return a boolean as well, so that you can be sure whether that key is there in the map or not. Okay, so similarly I'm gonna do the same, and here the operation is gonna happen on the front. Okay, so if queue dot front is nil, then I'm gonna return an empty value. Okay, let me say firewall T, and then I'm gonna return all comma false. Okay, so I'm returning false because the queue is already empty, and then you shouldn't be using the value at all. Okay, so now if the queue is not empty, then I have to take the front item, which is val equals queue dot front dot val. Okay, so that's the value. I've taken the value, and then I'm going to say queue dot front dot queue dot front equals queue dot front dot next. Okay, so and then I'm going to say return val comma true. So now I have the value already copied here, so and that value will be returned along with the true. Okay, so that's queue. Now I have updated the front so that the front moves to the next. Okay, so now we have only one more operation left, which is peak. Okay, so here again I'm gonna say q of t and then peak is gonna have the same template. It is gonna have the same return type. Okay, t and bool. If so this will be the same. Let me copy this, and then I'm not gonna update anything. Okay, I'm just gonna return the value. I'm not gonna update anything, so I'm gonna say yeah, this is fine. Okay, so now I'm just gonna copy the value from the front and then returning the value. I'm not at all gonna update the pointer. Okay, so it will still have the front as the same front after peaking as well. Okay, so now we have all the operations ready. Now let's test this. I go to the main.go, and then here I'm gonna create a new queue. I'm gonna say queue equals a new queue, and this queue is not gonna have any value. Let me see if I can import this. No. TSA and then queue. Okay, so now and in the queue we have to give parameter as well. Since we are using generics, we're going to say what is the type of the item that we are going to add within the queue. Okay, so I'm specifying int now, but then you can specify any type. It can be even another structure. Okay, so I did this, and then I'm going to say a for loop, and then here I'm going to say I'm looping till 10, and then q dot in queue I. Okay, so I'm adding whatever I is the value, which is going to be 0 to 9. I'm going to enqueue it to a queue, and then I'm going to dequeue and print the same. So now again I'm going to have a for loop. Let me have it as j. Okay, and this is going to have 10, and then q dot dequeue. Here, since it is returning two values, what I'm going to do is that val comma okay equal to this, and then I'm going to add an if statement. Okay, and then I'm going to check if the okay is true. Only if the okay is true, then we have a value, otherwise we don't have a value. Okay, so in that case I'm going to say fmt dot println. I'm going to print the value, otherwise what I'm going to say is that break. Okay, so else has to be here. Okay, yeah, So what I'm doing is I'm just looping through and adding a list of 10 items to the queue, and then dequeuing those items and printing to the screen. Okay, now let's try running this. It is not at all working. Let's check why. So if you see, actually I have declared this as without pointer, so it has to be pointer here. Only then the updates that we make will happen on that exact item, otherwise it will happen only on a copy of that item if it is going to be a value. So it is important that it has to be a pointer. Okay, so here I need that again, and then here I need that again. Okay, so now we have updated it. Now let's see if it is working. Yeah, so I added the item in order, so the DQ of that item is also returning the item in the exact order. If it had been a stack, then you'd have got 9 at the first and then the other items in the reverse order. But since it is a queue, you are getting in the same order. We're gonna test one more edge case here. A queue is not gonna be enqueued together and dequeued together like this in a real world scenario. Actually what will happen is that enqueuing and dequeuing will happen repeatedly. So to test that, what I'm gonna do is I'm just gonna have a for loop again, and then add 10 items again, and then dequeue 10 items again. Okay, so this way we can test like the edge case is working fine. That is, when the queue is empty again, and then when we are filling it again, it should work properly. Now let me run this. It is not working, so which means that the queue is getting emptied, but then it is not being filled up again. Probably we are missing something in DQ. If you see, we are updating the front, but then we are not updating the back. So whenever the front is nil, which means the queue is empty, then back has to be updated to nil as well, otherwise it will be pointing to the previous item, which is inconsistent, and that could be causing the issue. Okay, so just we'll update that, and we'll go to main and run it. Yeah, now it is filling once, dequeuing and printing everything, and then filling it again, and then dequeuing again and printing. Okay, so everything is fine now, but then this queue is not concurrent safe, which means you'll not be able to use the same queue in multiple coroutines and enqueue and dequeue at the same time. As long as you are using this in single coroutine, it is fine. So let's see how to make this queue into a concurrency safe queue in our next video. If you don't want to miss it, subscribe to the channel, and please share your feedback on this video on the comments to make it better. Thanks for watching.